Yeah, welcome. This session we'll talk about force components. Yeah, actually there are two types of components are there. First, let us name them. So, first category are called rectangular components. Then the second category is oblique components. Okay, so there are two components. So first category is rectangular components and then second category is oblique components. So coming to what exactly is the force components mean. Okay. So it is just the inverse of finding the resultant. So you might have learned finding the resultant by replacing the force system with a single force called resultant. So here it is inverse of that process. Okay. A single force can be replaced with many number of forces. Okay. So those forces that are called components of a force. Okay. So for example, consider a body. Let there be a force acting on the body. Okay. Now I would like to replace this force with its components, maybe any number like 2, 3, 4, like that. Okay, so let us first go with how to replace this force with two components. Okay, so you have two options. One is rectangular components, the other one is oblique components. So what does it mean, rectangular components? Rectangular components means the two forces, the two components, the components, rectangular components mean the two components that you are replacing with a single force that shall make 90-degree between the components. Okay, so the angle between the components is 90-degree. Then we call those components as rectangular components. If the angle between the components is not 90-degree, okay, then any other angle, like if it is not 90-degree, 0, 90, 180, okay, so something like that, 270 further. So if other than these angle, okay, if the two components make other than these angles, we call them as oblique components. Okay. For example, so consider a body where you have a force applied on the body. Okay. So first let me draw the rectangular components. So this is say x direction, y direction. So now if you project this force onto this axis, okay, so this we call it as x component. Similarly, you project this onto y axis, okay, so this we call it as y component. Okay, so you see these two components will make 90-degree between them, right? Similarly, oblique components mean, as I said, other than these angles like 0, 90, 180, 270. Okay, so let me consider the force again. Okay, now the oblique components, how do they look like? So for example, this is the direction of one of the components. Let us say some x dash. Okay. Similarly, the other direction, some other direction, say y dash. Okay. Or else some other x double dash you take. Okay. So if your forces are along these two components, okay, these two directions. So this is not a 90-degree. This okay, this is not a 90-degree. Some other angle, okay, whatever may be the angle. Now how you plot the components? Draw a parallel line at the head of the arrow. Okay. So now this is what you get is fx dash component. Same, draw a now parallel line to this x dash line. Okay, draw a parallel line like this. Okay, now this length, what you get here is fx double dash. So these are oblique components. Okay, so this is the clear difference between the rectangular components and oblique components. Okay, so what if the angle becomes zero between them, the components? If it is zero, they become collinear. Even 90, they become rectangular components. The angle is 180, again they become collinear. Okay, the two components are aligned along a same line. 270, again they become rectangular components. Okay, so that way, other than these angles, if you have components of a force, we call them oblique components. Okay, but in solving the problems of engineering mechanics, we mostly opt for rectangular components because they are easy to deal with. Okay, as you see, I can easily find the components value of the component. For example, if this is the angle theta between the given force and the x-axis. Okay, so now let us see, if I take cos theta, the trigonometric quantity cos theta. Okay, the adjacent side, this is the adjacent side, the value is fx. By hypotenuse, it is f. So fx value is f cos theta. Similarly, if I take sine theta, the trigonometric function sine theta, the opposite side is equal to fy. These two are equal. So it is fy by hypotenuse is f. Now fy value is f sine theta. So this is how you can easily find the values of components, right? I will come back to the oblique components in detail in the next lecture. Thank you.